Today I'm going to show you how I connected up my AutoZero touch-off block and how I configured my machine. Hello fellow CNCnutz and welcome. Well, as I promised, I'm going to cover the installation of a touch-off plate like this one here, and I'm going to cover it on two separate videos. One will be covering CNC and the other one will be covering Mach3. So just pick the one that's appropriate to you, or if you're interested, why not watch both? So I've started off with the touch-off plate. In my case, I'm using this here. It's a block aluminium. It's 20 millimeters thick, and it's about 3 inches square. I made this by simply drilling a 4 millimeter hole into it, and that will accept a standard banana plug like so. Now, of course, you don't have to use something like that. Another option is something like this here. This here could be used as a touch-off. It has a single button up here that you can actually push down on. It's not actually a button as such. This here is actually the contact, but if the cutter drives into it and doesn't stop for whatever reason, the button will actually depress, and it gives you a chance to actually manually stop the touch-off process, so should something fail. So that something along these lines is another option. There's plenty of designs for touch-off plates like this. Now, another thing is, it's not possible for me to cover every scenario that there is out there. I'll cover both CNC and Mach3 from the installation of the macros that we'll be using and how to program the required pins and ports. But as far as controllers go, I'll just be covering this one here, which is a Gecko G540 drive, because this is the one that I use. However, what I'm saying basically applies to them all. Now, in general terms, on a CNC machine, some of the pins are set aside on the parallel port for driving the motors, some are set aside as inputs, and others as outputs. So, I'm going to show you on here, my Gecko G540 drive, how I connect it up. Here is the parallel port. Now, this connects back to my laptop parallel port, or my smooth stepper, or my UC100, and in actual fact, in my case, a UC300 Ethernet controller. And I'm going to be using pin 10, which is actually the first input port, and it will come out the back here on the G540 as one of these connection ports here. Now, your stepper motor driver, be it a Gecko G540 or a Xylotex unit, a lead shine unit, or hobby CNC, whatever sort of drive you've got, should have the same sort of arrangement. And if it doesn't, you'll have to get a breakout board that will allow you to get access to these pins here. What I like about the Gecko drive is all the outputs and inputs are optically isolated, so there's no chance of damaging the equipment that plugs into it. I don't know about other drives. Now, a touch-off plate is one of the simplest additions you can do to your CNC machine. Simply run a wire from my Gecko drive here, put a banana plug on the end of it, it plugs into the hole I drilled in the side of my block, and I can place the block under the cutter like so. Now, the other end of that wire comes back to here and connects to one of the input pins on the rear of my Gecko drive here, which ultimately makes its way through the parallel port, pin 10. Now, the second wire typically is also run from the Gecko drive and would be terminated with a clip lead. That clip lead simply clips onto the cutter like so, and the other end of it goes back to the Gecko drive's ground. Now, by ground, I mean the negative rail of the Gecko drive's power supply. Do not confuse the Gecko drive's ground with perhaps the spindles ground or earth. They are two entirely separate and potentially isolated circuits. In my case, they were completely isolated. So the earth on your spindle is designed so that if anything goes wrong in here and the body of this here becomes live, then it will be shunted to ground through the 3-pin plug on the wall there, and that will stop me and anybody else around here being electrocuted, for which I'm immensely grateful. Now it's it's possible that you may find the negative rail of your power supply is already connected to mains earth and ultimately may find its way all the way through to the spindle here. I did it by simply running a wire from the negative rail of my Gecko's power supply all the way through to where it could connect to the spindle, and that basically grounded that. Now it's important that should you find that the spindle is already grounded with respect to the power supply of your Gecko drive, do not run a second wire. That will create an earth loop and you'll be chasing faults till the cows come home and you finally figure out what it is and rectify it. Since this here is now connected back to my Gecko drive, I don't need this extra wire anymore, which is going to make my life a bit simpler. However, not all spindles or routers, laminate trimmers or Dremels can be grounded. Some of them have plastic bodies and don't have an earth pin. Some of them, for instance, a high-end spindle may have ceramic bearings, which is going to insulate the collet, the armature here, and therefore you're not going to have grounding. If you're not sure, you can get away with just simply using the clip lead. But there's also a very simple test as well you can do to find out whether or not your equipment is already grounded. Once you've configured up your software, take your clip lead banana plug, touch it to the body or the cutter, and you'll be able to see whether the pin lights up in your software. That's going to be one of the tests you need to do anyway. You need to make sure that that works. If it doesn't, you may find that you will need to go with this clip lead. If it does, then you probably won't need one. Okay, so it's time now to have a look at our software. I've opened Mach3, and the first thing I need to do is I need to open ports and pins. Now I'm just using the standard 1024 set that comes with Mach3. The same applies to pretty much any screen set you wish to use. I'm coming into input signals, and I'm just going to scroll down here until I see a line with the word probe. I'm going to click to enable. I now need to input my port number. Now I'm using parallel port 2, and it's going to be pin 10, which is the first input from the Gecko G540. It needs to be set to active low, and I go apply and OK. Coming over here, I'll just do a save settings. We can now check to see if our probe will work. So now that we've got the digitized port programmed up in Mach3, we can now test it. Take our block with our connected wire, and if you're using the clip lead in conjunction with this, simply touch the clip lead to the block like so, and we will see the digitized port lights up on the diagnostic page. Disconnect it and the light will go out. Alternatively, if you're not using the clip lead but using the cutter as the other part of the circuit, then simply take the block, touch it to the cutter, and we should see the digitized light come on. Disconnect it and the digitized light comes off. If that happens, you're ready to move on to installing the script. If that doesn't happen, you need to go back through and either recheck your programming, make sure that's correct, or go through and check your wiring because you have an issue with one or other of those two items. So before we move to the Auto Tool 0 script installation, let's just take another quick look and port some pins, input signals, and we're just going to go back to our probe here. Now you'll note this is called probe, but for some reason known only to the creators of Mach3, they changed it to the digitized port on their diagnostic page. So thank you very much for making that as confusing as possible. So now we're ready to install our script. I'm going to come up here to Operator and down here to Edit Button Script. When I click on that, the Auto Tool 0, the Display Mode button, the G-Code button, they all start flashing. I'm going to hit Auto Tool 0. Up comes a script editing box. I'm going to just highlight what's in there and just delete that. And you may find you already have an entire script in here. If you want to save it, just copy and paste it to a document somewhere before you replace it. It's entirely up to you. But I'm going to come here to Auto 0 Mach3 metric 2-pass script.txt. This file I downloaded from my website. I'll double click on that and open it up. I'm going to just go Control A, Control C to copy it. I come in here and go Control V. And that's basically pasted the script into here. We can now close this page as well. So before I do anything else, I'm just going to go Save and save that. And now we can have a closer look at it. Now this here says it's the metric version, and up the top here I've got a date on the first line. If you're not sure if you've got the most up-to-date version of it, just simply check this date here and that'll tell you whether you've got the latest one or not. So we have here some parameters. We have a downstroke of -25 millimeters. In the Imperial version that would be 1 inch, so it's got -1. We have a down feed rate of 250 millimeters, so that's 10 inches in the metric one. So there's no real difference between the metric and imperial, except I basically divided all these figures by 25. You can change these figures if you wish, but they seem to be about right from my testing. The retract stroke here of 20 millimeters is how far the cutter will bounce back up after it's set 0. So in this case it'll bounce up 20 millimeters above the surface of the block. I'm going to change mine to 10. I've got a retract feed rate of 1000 millimeters per minute. Here I have a plate thickness. Now this you do definitely need to change. My plate thickness is 19.88, which I found by measuring with the calipers. Now here I have a small retract stroke. Once it's done its first pass, it will retract by 1 millimeter. That would be 40,000th of an inch. And then makes a second pass. And down here we have a second feed rate of 25 millimeters per minute, which is 1/10 the feed rate of the original one. So like I said, you can change any of those you like, but these figures are about right. You definitely have to change this one here. And it's got written there, enter Z plate thickness here. So I'm just going to go, if I can get it right, File, Save. And we'll close that. Now that we've got our script installed into Mach3, it's time to give it a test. And the very first test we're going to do is we're going to make sure again that once we touch this block to the cutter, that the digitized light comes up on the diagnostics page. If it doesn't, do not continue because it will not work. Now what I've also done is I've put a 3 flute cutter in here. It's something that basically has quite a large footprint on it. Don't use a V-bit for these tests because if it doesn't work, then it'll try and drive that point into the aluminium here and it'll break the point off, guaranteed. One thing to consider is if when you do touch this here to your cutter it doesn't light up, it's probably because you're meant to be using a clip lead and have probably forgotten to clip the clip lead on. Okay, so the next thing I'm going to do is to make this a little bit easier, or to give me a little bit of wiggle room if things doesn't work out properly. I've driven the axis up quite high, and what I'm going to do is I'm going to hold the block just here like so. Not going to put my fingers under it in case it comes down and tries to crush them. It's a bit unlikely, but never know. But I can hold off to the side like this here, a little bit below the cutter. I'm going to let it come down. It should touch off, go down again, touch off a second time, and raise back up again. If it does that, then we'll do some even better testing. So I'm going to come here into Mach3, go Auto Tool 0, and it says to enter the material thickness offset. I don't need a material offset thickness for this, so I'm just going to go enter. I could also put 0 in there if I wanted. Now the cutter comes down, touches the plate, leaps up a little bit, comes down a second time for a second pass, touches it, and raises up above the cutter. Next, I'm going to take a block of MDF and put my touch-off plate on top. I'll just bring the cutter down a little bit closer to it, and again do the Auto Tool 0 and just hit enter because I don't want an offset on this. Once this is done its offset, we're going to check to make sure that we have the correct thickness for our tool setter. I'm just going to go to origin point. That'll drive my Z-axis down to 0, and now I can check to see if that cutter is sitting perfectly on top of the MDF, and it is. I can't lift it, but I can turn it without it gouging anything out of it. So that's set with the correct thickness for my tool setting plate here. Now you can get that thickness by simply using a pair of digital calipers to measure it. And if you find that it's not quite right, what you can do then is just alter that figure slightly in the script file until it's correct. Now, as a bit of a hint, if there's a gap between the cutter and the MDF here, then I would increase the thickness in the script file, and if it drove itself into the MDF here and started cutting it, then I would decrease it, and just keep testing like that until I got the final perfect figure. Now the other test we can do is I'm just going to bring it forward like so. I'm going to do the same test again, but this time I'm going to do with the block onto the table surface. I'm just going to go Auto Tool 0, and this time it's 18 millimeters. So I'm going to enter 18 and go OK. Our cutter touches off a couple of times and sets itself to the final retract height. And now I can go origin point. You can see here the cutter is returned back to my stock and is sitting on the surface of it. Now don't be alarmed if you find the cutter is sitting a little bit above the stock or a little bit below it. The cutter is now 18 millimeters above the surface of the spoil board, and my stock probably isn't 18 millimeters. In actual fact, mine's a little bit more than 18 millimeters, so it's pinned to the spoil board. And that's the whole point of this exercise anyway. It's to compensate for inaccurately sized stock. Okay, well this is working, so I'm going to give it 2 thumbs up. So, question of the day, what value should I enter when using the touch-off plate? And I'm presented with the question of what the material thickness offset is. Well, it's very simple. If I have my block of material here and I put the touch-off plate on top of it, the answer is simply 0. And we don't even need to type in 0, just hit the enter key and away it'll go. It'll touch off the surface and 0 will be set to the top of the material. So the next question is, when I put my block on the spoil board here, what's the nominal thickness value I should use? Well, again, the answer is very simple. It is the nominal thickness value that you used when you created the file in your CAM software. So let me elaborate on that. if I was creating a file for this piece of 18mm MDF, I would tell my CAM software that this piece was 18mm thick, and when the G-code was imported into my control software about Mach3, UC, CNC, Linux, CNC, what have you, as far as it's concerned, the material is 18mm thick. So when presented with that question and setting my cutter with respect to the spoil board, the answer is easy. It's 18mm. And 99.99% of the time, you're not going to have a problem with that. But if you remember back to last week's episode, I didn't have the file to create a new section of G-code for the piece I wanted to cut. And it was created for a piece of 18mm plywood. Unfortunately, the plywood I was using was just under 20mm thick. So when presented with the question, what is the nominal thickness of my material when I set the cutter onto the surface of my spoil board, the answer was very simple. It was 18. That's what I told my CAM software it was. That's what my control software expected it to be. So just be aware of that. It isn't necessarily the actual thickness of the material you're using at the time, though most of the time it will be, because you'll be using files specifically for that material. But if you're changing material like I did, it's always the nominal thickness value you told your CAM software that the material was when you created the file. Well, there you have it. Wiring up the touch-off probe was really easy. Configuring our software was really easy. And remember, you're not stuck having to use this particular style of touch-off. You can use this style here with a movable touch-off button, so that if anything goes wrong, you've got an opportunity to push the emergency stop button and prevent a disaster with your cutter. What style you choose to use is entirely up to you, and there are plenty of different styles out there. If you're looking for the files I used, follow the link directly under this video. You'll be taken to a page to where I have the files saved. You can download the ones you want to use, and just check you're using the most up-to-date version. If you find anything wrong, please let me know. I'll get it fixed and updated as soon as possible. Well, that about wraps it up for this episode. Don't forget to like and subscribe, and join me next time. I have no idea what we'll be doing, but there's a good chance we'll be using our new touch-off plate. Okay, cheers.